Welcome back. This is an Aleks teaching homework video on calculating mass density. So density, remember, is whatever the mass is of an object divided by its volume. So you can use that in chemistry to determine what you've got. If you can figure out its volume and figure out its mass, then you can figure out its density and then use something in a book somewhere to tell you what something's density is. You could identify an object or a substance. And that's what it's doing here. So your question says, a chemist working as a safety inspector finds an unmarked bottle in a lab cabinet. A note on the door of the cabinet says that the cabinet's used to store bottles of acetone, diethylamine, dimethyl sulfoxide, glycerol, and ethylamine. Okay, big old chemically names. So each one of these chemical names can be found in a book and the density of that substance can be looked up. So it says the chemist plans to try to identify the unknown liquid by measuring the density and comparing to known densities. First, from his collection of material safety data sheets. Every chemical in the lab has one of these sheets. It says all about the chemical. The chemist finds the following information. So we'll look back at this in just a minute. Here's the density of each one of these materials. You're going to figure out the density of the unknown stuff and then compare it to this table and figure out which one it is. That's what you're going to do in this problem. So here's the question. Next, the chemist measured this volume of the unknown liquid as 1,796 cubic centimeters and its mass as 1.27 kilograms. Okay, so he weighs it out and finds its volume. So you're going to need to know a couple things because they're asking, your first question is you have to find the density of it and record it in grams per milliliter. That's the normal units for density. So that means kilograms have to be converted into grams, and also cubic centimeters also has to be converted into milliliters. Let's do the cubic centimeters first. That's an easy one. It's by definition the same. 1 milliliter is by definition equal to a cube that is 1 centimeter by 1 centimeter by 1 centimeter. Centimeter by centimeter by a centimeter. So a cubic centimeter is a box. And the liquid that contains, the liquid that box of that size contains, is defined to be 1 milliliter. Okay, it doesn't just happen to be that way. They made it that way. They defined it to be that way. So the first thing is that 1,796 cubic centimeters is the same thing as 1,796 milliliters. Now in nursing, they don't call it milliliters, they call it cc's, and they call it cc's because it's cubic centimeters. So a cc in nursing parlance is cc cubic centimeters. It's the same as a milliliter. All right, so that's the first thing. Next thing we're going to need is to turn the kilograms into grams. So I have 1.27 kilograms. I want to get rid of kilograms and go to grams. Kilograms is bigger. So how many grams? It's going to be 1,000 grams. Because kilo means 1,000, so 1,000 grams in a kilogram. That means I'm going to multiply and I'm going to move the decimal point 3 spaces. Okay, so when I multiply that, I probably am just going to put it in scientific notations, the easier way rather than say 1,270, so that I can keep 3 significant digits here. I'm just going to say it's 1.27 times 10 to the third grams. Okay. All right, so I have everything I need. I want density. Remember density. I think they use Greek letter rho for density. Don't know why. And it's going to equal mass over volume. So there's our formula for density. So density is going to be our mass. So we're going to put our mass on the top. That's equal to 1.27 times 10 to the third grams divided by our volume. Our volume is 1,796 mils. Check our units, grams per milliliter, grams per milliliter. That's fine. All right, so what is that? 1.27 times 10 to the 3 divided by 1796. Okay, that's going to be 0.707 grams per mil. So that'd be the answer to the first question. Given the data above, is it possible to identify the liquid? All right, so I go back here. So this is less than 1. It's 0.7. Okay, so 0.7. And does this round? Okay, because here, this looks like this is all in 2 significant digits. Can I put this in 2 significant digits? Yeah, I would go to the 2. That's the 0. Go 1 past. It's more than a 5. So it brings us up to a 1. So I've got 0.71 grams per milliliter. Yep, it's on the list. So I would say yes, I can identify it with that. And then which one is it? It's diethylamine. And that's when you're figuring it out. Okay, so not really hard. The math is very, very simple. It just looks scary. Okay, so hope you can do fine.